what you're going to see here in a minute is this part being made. This part is being made out of like a PREPREG resin, and the resin that this is made out of is still sitting here on this bench, and it's still in the gooey stage. And what makes this video so unique is the fact that this resin is probably close to a week old, but this part that's fully cured at 300 degrees is a usable part. This part was made out of this cup of resin. So what we've got here, and I'll explain it and I'll show it to you in this video. HTR 350, Resin Services Clear Resin, and the hardener is 8401. So the hardener, it stays liquid for an extended period of time. So in effect, what I've done is created a PREPREG that I could use anytime to make parts. Now, I made this Bellcrank out of this resin, but I think the resin with the properties is probably more suitable for different applications in this part. I pretty much have this part figured out. The reason why I made this part out of that resin is because if something went bad, I'm not going to forfeit a huge amount of material. You know, it's all good because it's not a big expenditure, and it's something that I wanted to try, because if I can get this carbon to conform to this mold with this resin, it's probably the most extreme because of these little dowel pins, you know, the carbon that has to wrap around them at 360 at an 1/8 inch OD. It's pretty tough to get this thing packed down. Now, that being said, when you watch this video, it goes pretty quick when I lay this up because it's already been pre-pregged, but there was a couple voids in this part, and I went back and just put a little carbon in there. Fixed up the cosmetic things. It's still a usable part. I'm not going to give it away or sell it. Basically, it's going to go in my airplane. And after putting it under a stress test, I'm satisfied that, you know, it's going to be good to go. But cosmetically, it's not as beautiful as some of the other parts I made. So watch the video, fast forward through it, and then you're going to find me laying this part up. And then at the end of the video, I'll come back and talk a little bit more in detail about these two components, the resin and hardener, and what they can do for you and what they can't do for you. You know, it's still wet. Now, one of the things you want to do with this process when you create your own pre-preg, it's beneficial if you want to handle it and store it, is to put it between plastic sheets. So right now it's laying on a piece of plastic. This plastic is leftover ultra coat backing. You know, when you buy the fabric, or you buy the iron-on covering, this is the backing, and it's pretty durable. It's thin. So the advantage of having it on plastic is you fold it over, and that way you can handle it. You know, you can move it, and you can also cut it. Now, let's just say this wasn't tow. Let's say this was a fabric. Well, that makes it really easy to handle. So what you do is you wet the fabric out, and then you would squeegee it under the plastic, get as much resin out of it as you could, and then when you got ready to use it, then you'd cut it, and you'd cut right through both layers of plastic and the fabric. So that way you're not cutting wet fabric, you're cutting wet fabric that's sandwiched in between the plastic. And that, once the plastic is on top and bottom, it holds it into place too. You know, things don't go crazy on you. So that's where I'm at. I got some of this tow, and it's wet out, And the beauty, let's just say you come back today and you think, yeah, it's a little wet in this spot, or you can go with paper towel and blot that up, or through the plastic you can run a squeegee over it and try to get more resin out of it. Surprisingly so, last night with this resin, it seemed like it wet out really well. It was wetting the carbon out better than I thought it was. And you got to be careful you don't add too much resin. Then you got to remove it. You want enough to where you remove some of it but not get it too wet. So that leaves us over here with this mold. So this mold was laid up with high temp resin, and the way this is going to work is preheat in the oven. I'm probably going to preheat it to 150 Fahrenheit. I'll heat that up. And that way, once this toe here works itself into that mold, it'll probably drop in viscosity. This right now in the garage is probably 65 degrees. Now, if it was 70 or 75, this still wouldn't be cured. So the temperature being cool out here is working to my advantage on this PREPREG toe. Now on this mold, since it's high temp, I'm not using the plastic UHMW cap. I'm using an actual metal plate. Okay, this metal plate's been polished. It's aluminum. And of course the bearing and the drill rod pins are all the same. So the oven over there is warming up. I'm going to place my Bellcrank mold in the oven and preheat it to about 170 degrees. And then I'm going to preheat my plate. And then when that happens, and I'll pull this out, and then I'll turn the camera back on, and I'll start laying this toe up in this mold. The other advantage of this high temp mold in this PREPREG system is the fact that I'm getting rid of the PVA. The warm mold should give me a really good surface. Once this carbon hits that mold, it'll start to flow and it'll give me a good surface finish. So it speeds up the process. This is great, and this is, I think, it's going to be beneficial and speed up the process. Will the end user know one Bellcrank from the other? No, they'll both work, they'll both be light, they'll both be strong. The advantage is, with this new system here, it's in production. It's able to make parts faster, more efficient, and with less money and time and money. You eliminated the PVA, you eliminated the surface coat, and a lot of things. So this is the resin, HTR 350, HT8401. Now this HTR 350, it's a lot like 250, but it's even thicker. If you look at this, I don't know if you can see here, 100 parts per weight HTR 350, 25 parts per weight 9234 right here. Or you can do 25 parts per weight HT 8433. So each one of these curing agents, this would be the fastest 9234. This was probably the medium, and if you want a PREPREG, the 8401 right here is what I've. So I took this over there, preheated this mold to about 160, 170. The other thing, you never know what the internal temperature is, but the outside temp on this mold is 170. That looks good enough. Now, like I said earlier, I got this PREPREG. This carbon fiber toe was wet out last night. And after sitting here all night, the viscosity hasn't changed. It's got Free Coat 700 NC on it. Now when it comes time to lay this up, I'm going to do the same thing, the same sequence as I've done on the other Bellcrank molds. I'm going to put the chopped toe in there. Now right off the bat, I can tell, since the Bellcrank is warmer, that this resin is flowing a little bit better. Now I've pre-wet this chop over here. I'm not wetting anything in the mold. Everything is pre-wet. So it'll be interesting to see how this goes since it's pre-wet. There'll be a couple problems that creep up that maybe I didn't anticipate with this method. But that's the purpose of this video, to see how it's all going to play out. Now it becomes obvious right off the bat how quick this carbon goes in the mold, just due to the fact that I'm not wetting it out. Right off the bat that I'm going to have trouble getting this stuff down in the mold and stay. It's obvious that it wants to spring back. So we're going to see how we can change that. See if there's something we can do to get this to stay in the mold. Let's put some chopped carbon in there. This is what I normally do, the chop. So I'm going to work some chop down in there, in the areas that have normal voids. Put some there and some out here. One of the things you have to be prepared for with this resin system that has the prolonged pot life, this pre-preg type stuff I've got here. When you grab a tool, whether it's your scissors or pliers, with wet hands, with wet resin, it's going to stay like that for a week or 2 weeks or more. And it takes getting used to, so you got to clean all your utensils up. Normally, if you grab your scissors with wet resin, you come back the next day and everything's fine because it's actually cured. This stuff doesn't cure until it hits the heat, so you're going to gum everything up. So you got to make provisions for that. So what I'm going to do here, I'm going to put a little chopped carbon in here. I'm going to see if I can actually hold this toe down in the mold with some chopped carbon. And hopefully this chopped carbon will suck up some of that extra resin and give me a little compaction. So this is working out pretty good. Now when I put that chop in there, it gave me some compaction, and that's what I was looking for. So I think once I get this system down, it might be one of these situations where it takes a lot less than 20 minutes to fill the mold. You want to go in, Smokey? Come here, Smokey. Come on, Smokey. Okay, here's a quick recap of what I did the other day, talking about these high temp resins that sort of fall into the category of a PREPREG. So here's the part that was laid up. Now this was sort of interesting because it was with resin that sort of falls under the PREPREG category. It's with a high temp mold. And this is the actual part you just saw me lay up. Now, the unique thing about this resin, and the resin is a HTR 350. It's Resin Services. It's this stuff here. And then the curing agent is a HT 8401. This curing agent 8401 is used in a lot of their casting resins that require a thicker casting. So it's a super slow curing agent that allows you to make a thick casting and get by the exotherm that would normally happen when you have a big mass. But when you mix this 8401 with the 350 and probably the HTR 250 also, I haven't experimented, it turns into a resin that basically is a PREPREG. Now, what I mean by a PREPREG is pre-impregnated. So I can't remember how many days. It's been 4 or 5 days, okay? This is the same resin I make the Bellcrank out of. And instead of being like a honey and dripping off of the brush here, it very slowly drips. So it's still not cured. It's not even to the B stage. It's just starting to get thick. Okay, so when I laid up this Bellcrank here about a week ago, I mixed up enough resin to actually wet out enough toe to do 2 Bellcranks. This is 36 inches. And as you can see, you know, it's just like the resin in the toe here. It's still, you know, still flexible and still wet. So when I laid this part up, and you saw that in the video, it was still pretty low in viscosity compared to the way it is now. And the problem was, if you watch that part of the video, it wanted to pop out of the mold. When you start laying this toe around these pins, the factor that makes this difficult on the layup is the toe wants to spring up out of the mold. Now, with this toe over here being tacky instead of syrupy, I'm hoping on the next layup I do with this toe that I can get by that where it'll stick down in the mold. Now, one of the advantages of PREPREG is when you peel the backing off, the plastic, the face and the backing, you expose the PREPREG. A lot of times when you lay PREPREG in the mold, basically you just peel off one side and then you lay it in the mold and you form it. And once you get it in the mold, it'll stick. Now, if the PREPREG is a little, let's say a little cold or whatever, you can tack it up by fanning some warm air over it like a hair dryer or a heat gun, and it starts to conform. which would be, you know, the case of this right here. You could still heat it up and it would start to conform. One of the things that happened when I started laying it up, this PREPREG toe that I made, is when I warmed this mold up, what had happened is it went from the bench to the mold and the resin dropped in viscosity. So is this resin, this PREPREG resin, the right resin for the Bellcrank? I'd say no. It made a Bellcrank and there was a couple little teeny bubbles, you know, I packed more carbon in it, but structurally it's fine. But it created some other problems, you know, because of the geometry and the type of resin. It made a good part. I mean, it's super strong and, you know, everything's good. So the PREPREG would be more beneficial to maybe a prop in a high temp mold, or let's just say instead of a prop it'd be a landing gear. So that's the story. But basically I wanted to lay the Bellcrank up because I wanted to try this resin out. So this was a good trial, because if something went bad with this, it's not like a huge mold, right? Just a small little sample mold. So going forward, I'll lay up another one of these and see what kind of properties I could get out of this resin impregnated toe that's been sitting here almost a week. I think where this stuff would really shine is if you're making tooling or you're making a big part. Theoretically, with this system here, that would cure, well, let's just say start to cure around 200 and then it cures around 300. The neat thing about this system is it would allow you to lay up a huge part all in one shot. So if you're doing a car hood or a boat or something, you could take your time with this system, lay it all up, vacuum bag it down, compact it, debulk it, and then subject it to the heat. The disadvantage to this system, and it's obvious here because in the cup, you know, here we are almost a week later and we still have gooey resin. The disadvantage of this system is it takes heat. And this resin in the cup is the exact same resin that I use for this Bellcrank. Okay. Now, when I laid this Bellcrank up, I put the metal plate on the top, closed the mold. Okay, it's got free coat on it. And then I clamped it. Now, it went in the oven, and the oven was probably about 180 to 200 degrees Fahrenheit. And I let it sit there for a couple hours. I just wanted to see what would happen to this resin at 200 degrees after a couple hours. What had happened is the resin was still wet. It was probably lower viscosity than when I initially put it in there, because when you take resin and let's just say it's center poise and viscosity 1000 and you warm it up, it might drop to 700 or 800 viscosity, which means the viscosity, it gets thinner. So when you heat it up, basically you close the window. Even though the resin takes a dip and gets thinner, your window of a resin that's wet becomes really narrow because it's going to shoot up really fast. One of the problems I had on PREPREGs when they gave me these samples from where I used to work, I bring home these samples I bring home these samples of PREPREG, and basically I just take 2 sheets of aluminum and I'd put the free coat on it or whatever, and then I'd actually clamp them, put them in the oven. And these things, these PREPREGs probably cured at, I don't know, let's just say 350 or whatever, but you know, they cure it around 300. I'd put it in at 250 and it would kick off really quick, but I wasn't getting the wet out I needed. What has to happen with the PREPREG is you have to have a nice window of low viscosity, not too low that you're sucking all the resin out of the material, but you want it to flow, because with PREPREG in this system here, you're going to go from a gooey resin, okay, and once you apply heat to this, the viscosity is going to drop and it's going to flow. And if you don't give it enough time to flow and debulk in the bag, then you end up with a part that's not optimal. So even with PREPREG, there's a schedule. You know, you start out at this temp and you incrementally increase it, and then you incrementally decrease it. So that's the deal with this system. So it solves a lot of problems, but it creates other challenges on the back end. This system here, this PREPREG type stuff, is it something that a hobbyist would use? No. And if you're a hobbyist and you're going to make, oh, I don't know what it would be, production parts or whatever, and you needed high temp, it would probably be the way to go. Now, one of the other problems I had when I was tinkering around with fiberglass and high temp resins, so what I do is I'd actually lay up the fiberglass with like HTR 250 1063, and then I put it in the oven like 200, 150, you know, work my way up. And here's what was happening. Number one, I didn't have the high slip mold release. I was using an old free coat, which was expired. That might have helped. But what really makes the difference on aluminum is the thermal expansion. It's either going to hurt you or it's going to help you. Now, what do I mean by thermal expansion hurting or helping? Go back to the tube where I wrapped this tube with fiberglass and HTR 250 1063. What would happen is that resin would cure hard before that tube actually reached full expansion. So as the tube or the bar stock or your mandrel is heating up, it's not growing much at 150 to 200. And if you have that 150 for 2 or 3 hours, or you know, you got a long soak, basically that resin is hard and the tube hasn't expanded fully. So you keep raising the temperatures, now you have an extreme force between that part and the tube, and you get no more compaction because your resin is already cured. So for the thermal expansion to work in your advantage, the resin has to stay fluid at a really high temperature, so that way when the resin finally cures, your mandrel is fully grown and everything comes together. The aluminum expands and then your resin cures hard at that expansion rate. When the part cools, your aluminum shrinks, but your fiberglass or carbon fiber part, tube, or in my case the tube, would stay the same. So in effect, when the aluminum mandrel would shrink, it would release itself from the part. And it became apparent on some of these things where aluminum expansion on a mold was not your friend. So I used to go into a place called Aerodyne, and this was back in it might have been the late 80s, early 90s. So Dan and Randy Rodine owned it. They've since sold it and they're retired. But we'd go in there, and there was a handful of us in the Indy area would go up there and talk to them. And we'd go up there and we'd try to bum scraps off of them and buy little cans of mold release and stuff. And I posed the question to them more than once about aluminum tooling. Aluminum tooling, if it's a right geometry, is going to work in your favor. they were making funny car bodies and a lot of larger stuff, and they said they never use aluminum for those molds. Obviously, maybe one being the cost, but even if the cost wasn't a factor, they wanted the coefficient of thermal expansion between the carbon fiber mold and the carbon fiber part to be the same. Now, let's just take for an example a funny car body. Okay, so let's just say in theory you can make that out of metal or of aluminum, and you've got to post cure that in a composite oven, autoclave, under a lot of heat. And if you take from front bumper to back bumper, that thing, I don't know the math on it, but it would grow so much that it would distort the part in an extreme amount. So that's my theory on aluminum. If you have an aluminum mold and you cure the part in the aluminum, let's say at 125, 130, where you're not getting the expansion like these glider wings you see, you're probably going to be okay. The other option is to cure it at room temp or maybe 130 degrees in the aluminum mold, pull the part out, assemble it, do what you have to do, and then post-cure it outside of the mold. The problem with post-curing outside of the mold is you still have to support the part. If you ramp it up just a tick too fast, it's going to become soft and it's going to distort. So just like the resin that you just mix, when it gets warm, the viscosity drops. It's the same thing when you're post-curing a part. If you post-cure a part that's fully cured at room temp and you want to take it to 150 and you take it slow, very slightly, maybe not noticeable, but it's going to become soft. And then when you take it to 200 degrees, what was hard at 150 becomes a little soft. But once you reach that top end temperature, then you'll be locked in. And the rule of thumb is, if you post-cure a part, post-cure a mold or a part, and you post-cure at 400 degrees, the part can be usable at 350 without distortion. So I called the tech hotline and I got a hold of somebody up here at Resin Services. I didn't have any spec sheets that mentioned 350 and 8401. So I asked him what the part per hundredweight of this 8401 was. And he said, and I verified it with him, it's 25% per hundredweight. So 100 grams of 350 would be 25 grams of 8401. Now, with the 350, you've got choices. You've got 9234 and 8433, and then the 8401. The 9234 would be your quickest cure, and it's still high temp. You're still looking at 350, 400, but your curing speed goes up. 9234 is a good one. 8433, which I haven't used in a part, I've used it in the castings, is your medium cure time. Still high temp, but it gives you more of an open window. And then of course your 8401 here, which basically you got wet resin a week later. And theoretically it would probably sit on the bench for a month or 2 months and stay gooey. So you're going to end up with an unusable resin until it hits the heat. How much heat? I didn't stick around at 200 too long. I ramped it up to 300, and it probably was a little bit over 300, maybe 310, 320. And that's when, after about 2 or 3 hours, I had this part here. After 2 or 3 hours, I had a usable part. The disadvantage of this Bellcrank at this PREPREG system, normally I don't cure them to 300, and I could have gone all the way to 400. But when I was soaking this at 300 for quite a while, this centered oil-like bushing, all the oil came out of this bushing. And if you look around this button, there's a little bit of porosity right in here where the oil leaked out. For some reason, it doesn't seem like it affected it any. I know maybe if you'd run a stringent test, yeah, but when I used to cure these, well, I still do at a lower temp, you didn't get the bleed out of the oil in the bushing because it never got to 300. But this resin system, if you want to make tubes high temp and you want to go all the way up to 400 degrees, you're good. And the gentleman at Resin Services I talked to, I can't remember his name, or I don't know if he even mentioned it, but he said the post cure on this, you know, 150, 200, 250, 3, you know, it goes all the way up, and it can go all the way to 400. So you can actually post cure this peaked out at 400 degrees. Going forward, it's like, well, what would be a good use for this pre-preg type tow, right? And one of the things, and I talked to a few people that use these aluminum brackets in these airplanes, and I know they're pretty decent weight. Okay, so they've got the weight down because they machined them quite a bit, and I'm talking about in the center of the fuselage where the Bellcrank goes, the aluminum bracket that extends out that ties your wing into the fuselage. Okay, so they machine this aluminum down, and they've gotten the weight down a lot, I think, compared to what they used to be. With that being said, it could still be lighter than that if it was carbon. So let's just say you had an aluminum plate, right, and you built up the plate with like other sheets and you screw it down, so in effect you create a cavity, and you wouldn't even have to have a draft angle, right, because these pieces that you screw down to this plate could be vertical and the part's still going to release, because when you unscrew these plates, you're not pulling the part out of the mold, you're just removing the sides of the mold to expose the part. So a lot of these brackets could be made with this system, carbon tow, and with this pre-preg packed in there and then vacuum bagged and put in the oven. One of the advantages of, if you made those brackets out of carbon, you can actually glue this to your structure. You don't have to wrap it with Kevlar to get the bonding joint between the aluminum and the airplane. So in effect, the bracket could be in the center of your fuselage with your Bellcrank, instead of ending at a stub and then having a stub here that connects to it. The stub would be really thick here where it bolts, and then it would taper, and you could run that glue surface over 6-8 inches to get more of a purchase area to, you know, to spread that load out. So that's just something to think about. But this deal here, 350-8401, it's really out there, and it's really not a hobby-friendly resin because how much post-processing it takes with the tooling and the heat. One of the things I've looked into, I sort of skimmed the surface. I looked into like a Cerakote oven. You can buy these things, and they're, you know, they're as big as a refrigerator or as big as half this garage, I believe, you know. But if you'd get a Cerakote oven, maybe vertical, and that way you could put a whole airplane in there. Now, not whole airplane together, the components, you know, the wing, the tail, and the fuse. And you could vacuum bag them and cure them. So it would allow you to do larger parts. Now, the way this is set up in the garage here, I've got this warming box, and that's all it is. Basically, it's 140 max. I never put it up over 140 because obviously it's a wood structure. But this is just like a little incubator to get room temp resins or get the room temp cure. on a high temp resin in a cold shop, because you know you're looking at 65 degrees out here in the winter. Anything above 140, I take the component and I take it into the composite shop, and they have autoclaves, which you know wouldn't be beneficial at that point, but they have big ovens, you know, you could put the whole part in there so they could post cure it. You know, it's just a hot oven that you can pull a vacuum, but there's no pressure. So that's it in a nutshell. This is the part. It's usable. The experiment was a success. I was able to find out that yes, I could actually make this work. One of the other things to remember, if you do, let's say you're laying up wheel pants or something. If you pre-wet your fiberglass cloth, carbon, or whatever, and you wet it out on a piece of plastic, and then what you do, you fold the other half over the top, so you've got a sandwich here, so you can actually handle your wet resin through the plastic. And then you take a template, let's just say you needed a piece of carbon or glass, whatever you laid up here this size. You could trace around it with magic marker, and then you take scissors and you cut this pattern out, and it's wet resin. So in effect, you're not handling the gooey wet resin, you're handling a piece of plastic with, you know, your fabric and your resin in between the sandwich. And then what you do is you peel off half of it, okay, half the plastic, and then you flip it over, and then you can put that in the mold. Now, one of the things you can do, you can buy a release plastic, and the composite shops sell them, and they use it a lot in autoclaves and stuff. It's a backing that goes against your peel ply that allows your breather cloth to separate, and there's a lot of other uses for it. But you can actually leave that backing, that release plastic, on there and vacuum bag in your mold, and that way you never actually touch the resin. What you do to actually allow that to bleed out is you take like a woodpecker with all these little sharp points, and you roll a pattern on that one side of the plastic, so that way when you actually lay it in the mold, the perforated side would go out, so then when you vacuum bagged it, you'd still get a little bleed through that release. And you'll see people on videos do it, and the resin will come up through that little hole, and then it'll spread out in your peel ply, and also your, maybe not peel ply, but it would spread out in your breather cloth, which in our case could be paper towel, works good. So there's a lot of things to think about. There's a lot of things changing in the hobby, I believe. Conventional airplanes are great. The balsa wood, it's still a beautiful system to sit down there and build a wood airplane. One of the things I think that caused this hobby to start moving in the direction of composites, alternate materials, is the scarcity of balsa. And I think what we're going to find out is we're going to be just as well off or better off without balsa. And that's a big statement. There's trade-offs, because on the back side of that statement is you're not creating an airplane, you're creating a system and a bunch of tooling to actually come back and get to that airplane or part. The upside of that is, if, let's just say you have a composite airplane, you made it or you bought it, and you go to the factory or you go back to your bench with the molds, and now you can make another one. It's just, you know, it's constant. You can just duplicate, you know, hundreds of parts out of the same mold. Joe Daly was working a crashed airplane, so they took you know, the balsa wood, and they formed it in the form he already had, you know, to duplicate that part that was broken off the front of that airplane. So it's a trade-off, you know. You're going over here for this, and you're picking up positives, and there's negatives. But no matter what way you go, there's always going to be the cost. So going forward, the HTR 350 and the 8401, I'll probably do some more projects where I'll try the 8401 in some different resins, see what happens. There's another thing, when you start mixing and matching different curing agents, once you understand the chemistry, and I don't mean like a chemist, but once you understand the reasoning behind their formulations and you can read spec sheets, you can really do a lot of things to change properties of resins. So a good example, I'll show you the cans here. Joe Daly bought some HTR 212, and this is the standard curing agent that comes with the 212. HT 386. Now this curing agent will get the 212 up there around the 300 degree temp. So basically, when Joe went from the resin surfaces from the West system, he doubled his heat deflection temperature. West systems, if the plane would have sat in a car, let's say he goes to Tucson to fly and he's got a composite airplane and it's sitting out there, the car hits 160 degrees, the resin becomes soft if it's West systems. Okay, so if he built his plane out of resin surfaces, HT 386 and the 212, if that was sitting in the car, the resin is getting harder. The longer it sits there, the harder it gets. If it's post-cured, the structure is good to 300 degrees at least. The other neat thing with the hardener, they got HT 386-99. What that hardener is basically the same properties, but it has a slower cure rate. What the -99 does, it opens your pot life up. So instead of kicking off, I don't know what it is, maybe 30 minutes, now you got a pot life of an hour. And since this is mixed at 33% per hundredweight, and you put it into a 212, which is thinner than the 250, now you've got a resin that's low enough viscosity that you can almost vacuum infuse. And if you don't vacuum infuse, it gives you a resin that you've got a lot of time to wet out. So if you're doing a whole wing or a fuselage, you don't have to worry about it kicking off and getting thick before you can actually get it in the vacuum bag. So that's something to remember. HT 386-99, longer open time. The beauty of this system is I know how it all works. And I can pick up the phone and call Resin Services and talk to somebody, and I have a question. I said, what's the ratio of curing agent of the 350 and the 8401? He put me on hold and he came back with a definitive answer. So I'm able to get concrete instructions and verifiable information I know that works. Resin Surfaces is one of just probably maybe 50 manufacturers out there. There's a lot of them, but I keep coming back to this because I know it works. I like dealing with them. They have fair prices, they're accessible. Pick up a phone, you can call them. They have a good product. It all works, and it's a product that a lot of people have been using for a long time. Now, with that being said, they didn't pay me to say this. They don't have salesmen running around the United States, you know, knocking at your door trying to sell their product. It's pretty much a closed loop of people that use it. A lot of fabrication shops, race shops, a lot of different people use their stuff. The other thing you can do, and I've stuck my neck out a little bit on this science fair project, I took some West Systems resin, their standard, what is it, 105, And I thought, I wonder what's going to happen when I take this HTR or HT386 at 33% per hundredweight and I mix it with West Systems. So I mixed up a batch. Lo and behold, it mixes well, it cures well, and the properties of looking at it after it's cured, it's really hard. I have a sneaky suspicion with this high temp curing agent that West Systems probably went from 159 degrees heat deflection temperature, probably in the mid 200s. I don't know, I'm not a chemist. I don't have the ability to run the tests, but I can guarantee you it's more than the stock resin and the heat deflection temperature. So if you run out of HTR 250 or 212 and you got West Systems, you know, you got some of this, throw it in there, experiment, you know. I'm not guaranteeing anything, but I can tell you on my tests that it turned out all right. So that's what I wanted to talk about. It's long and drawn out, but this PREPREG thing was a success, and I was able to get a usable part. Maybe the surface finish wasn't as ideal, maybe as you'd get on the gel coat. But this PREPREG resin systems, it's got a very narrow use, but there's a place called Algae Composites, and they're up there just east of the Speedway track, Indy 500 track, Speedway, Indiana. And I drove up there and talked to the gentleman, and I believe his name was Dave, and he basically showed me all the projects he was working on and explained tooling board and resins to me. But up at Algae Composites, they made a video on this system, this PREPREG HTR 350 8401, exactly like I've got it here. And what he was doing, he's taking carbon fiber sheet, rolling it out on the bench, and then he pre-wet it with a squeegee, laminate it between two pieces of plastic, and you've got PREPREG that's good for, you know, weeks or months. You could probably go months if you refrigerated it. I actually looked at the tooling he made with that PREPREG, and it looked as good as anything I've seen that's already purchased with normal PREPREG. There was no voids, and of course, you know, Dave was a person that had a lot of background in composites. He's done a lot of stuff, and he was really good at it. But going forward, it's just another little bit of information. Now, why would you want to go with this messy system? Why wouldn't you just go out and buy tooling PREPREG? If you're a small hobby shop or job shop doing hobby stuff, and you just want to make a widget, and this might work on a really narrow part. It might work on a part that's got a really specific use. The other advantage of this thing with the PREPREG over what you'd buy, what you make with this, is tooling PREPREG runs probably around, I don't know, I'm guessing. I think when he made the video or he talked to me, you're looking at maybe $150 a yard for a good thick carbon fiber PREPREG tooling fabric. He mixed up some of this stuff, wet out the carbon, and I think instead of like 150, 160, he was probably down at $37 a yard. So it's a considerable savings. The other advantages of this system is it's PREPREG on demand, and it can be PREPREG tow, fabric, or it could even be fiberglass tow. And PREPREG on demand means that if this resin is sitting in these cans and it's set aside in a good environment, not too hot, not too cold, and it's dry, it's going to last a lot longer than the PREPREG would. PREPREG has, even if you refrigerate it, it's got you know, a shelf life. Now, with that being said, I understand there's some pre-pregs that they claim, and I'm sure they're correct, that you buy this pre-preg and it's 75 degrees in your shop and you set it on the bench and it's good this month, next month, or whatever, it stays that way. So the chemistry on pre-preg has come a long way to where it doesn't necessarily have to sit in a sub-zero freezer. It's more user-friendly to the small shops. But this is user-friendly here. When you mix these two, you have a lot of options on what you want to pre-preg. And so that's pretty much it in a nutshell. Going forward, if I do any more projects that are unique or test samples, maybe with tubes and mandrels with this system, I'll go ahead and make videos. It'll be a video that not many people watch. If they watch it, it'll be for entertainment maybe, because it's such a narrow, what I want to say is such a narrow niche market. This system here would be something that a hobbyist wouldn't have any use for, but maybe he'd be inclined to watch it just for the information purposes. This is more like a small composite shop that would do repairs or do work on certain kind of real world race car stuff, industrial. But the neat thing is the epoxies and the adhesives in the full spectrum of things, they have cyanoacrylates that when you touch the glue to the part, it's cured and it's instantaneous. They have 5-minute epoxy, 15-minute, half-hour epoxy. They've got all these different formulas, all the way to the epoxy that takes months to cure, you know. And the beauty of this system is you can control when it cures with the heat. So it can sit there on this bench for weeks, and then you decide to make a part as soon as you put the heat to it, and now you got parts. So that's the advantage of this crazy system.